Okay, so in this lesson, we're going to talk about probability, right? What probability is, how is it used, and what is its purposes in mathematics and in other fields of scientific inquiry, right? So basically, probability is the likelihood of something happening, right? Probability is the likelihood of something. Probability is the likelihood of something happening. When when we in everyday terms, in everyday English, when we talk about probability, or um, when we talk about probability, or when we talk about it in every day-to-day sense, what we are really referring to is when we talk about it, when we say um, like the chance of something occurring. You know, what is the probability? What is the chance of this thing occurring? What is the chance of this thing happening? Right? Like, for example, what is the likelihood that today is going to rain? Right? There's a 50% chance that it's going to rain today. There's a 50% chance that the the coin that's going to be flipped is going to be, a tails. There's a 25% chance that your there's a 50% chance that your your child would be a boy or girl. Like, these are examples of probability, right? When we use it in an everyday to day to day, like, semantic type of sense, right? Um, Probability is fundamental to statistics, but it's also fundamental to this everyday to day things, and it's also fundamental to um, certain games like poker or like spades, something like that, where there is an element of chance to the game. Unlike games like, for example, like chess and Go, where there's complete information. Games of incomplete information like spades, poker. Um, I can't think of one other than those two, but like basically like um, card games that have an element of chance utilize probability. That's why when you go to certain places, like if you go to, um, for example, like if you were to go to um, like a casino or something like that, that a lot of the games are based on probability. They're based on, like Las Vegas, for example. There are a lot of games like they're based on probability. They're based on chance. A lot of the card games. Okay. Probability is broken down into two forms. They're broken down into theoretical probability and experimental probability. Okay. Theoretical probability basically is probability that is, by its name, theoretical, meaning that it's a probability that is assumed given the nature of the outcome of the nature of the outcome of the thing that you're trying to find the chance of. For example, if you say something um, like if you flip a coin, right? The theoretical probability of it landing on heads or tails is one half by its very nature, because there's only two sides to the coin, right? So if you flip it, right, based on the nature of the coin, there is a 50% chance that it would either land on heads or tails. That's the theoretical probability, right? It's the theoretical probability is the probability of something, or the probability of an event occurring based on the nature of For example, if you flip a coin, if you flip one coin, right? If you flip one coin, the probability for example, on heads is 50%. We know this because of the nature. We know this because of the nature of the coin. We know this because it is the nature. It is the nature of the thing that we are flipping, right? Another example of theoretical probability would be like if you let's say you're playing like a game that has dice, for example, right? And you say, like, say you have one die, right? Because remember, dice is plural. Dice means when you have two dies, right? So you have one die, right? And let's say you have one of those like dies like you play when you play like a game of Yahtzee, or when you play what's another game? Or like when you play what's another game that you play with die? Yeah, like Yahtzee, for example, right? And you say the die, for example, usually is like a instrument that has 6 faces, right? So which like has a little dot, or like if you play like like you play like something to like dominoes, and like say if you say and you're like, okay, we have these 6 faces on the cube, and each face has a dot, right? That has 1, 2, 3, 4, 5, 6, right? And let's say we flip that die, right, once, right? And we say, okay, well, what is the probability that the die will land? Let's say hypothetically, let's say that the die lands on a 2, right? Then we would say that the probability of the die landing on a 2 is 1/6 because there's 6 faces on the die, right? Right? If we wrote this as a percentage, if we wrote this as a percentage, this would be 6 goes into 40. How many times? 6 times. Or is that 17%, right? About. Right? About is 1/6 or about 17%. There's a 17% chance that the probability of one die landing on a 2 would be 17%, right? We know this because of the nature of the die. We know that the nature of the die has 6 faces, and that if you were to throw the die, if you throw one die, and you were to throw one die on the floor, and you were to estimate it, we would say, well, based on the fact that there are 6 faces on the die, that the probability of it landing on a 2 is 16%, right, or 1/6, right? Experimental probability is different. The experimental probability of something is when you actually do an experiment and you actually see what actually occurs as you actually do the experiment. So for example, when you the word for when you actually perform the experiment is called a trial. So the trial is when you actually do the actual like experiment and you see observably what happens when you conduct that experiment, right? So the trial is the actual performance of the experiment being conducted. To determine the probability of an event. So, right. And then the experiment is when you perform. The experiment is when you perform, the research necessary. It's the research being or the research being studied, or the thing being studied, the research being or the thing being studied, right? All right. So, right. So, for example, experimental probability would be like, if we actually did, like, say we had the coin, right? And we said, and we wanted to say, okay, how many times when we flip the coin does it actually land on heads? How much does it actually land on tails, right? So if we flip this coin 50 times, right, what is the probability of it actually landing on heads? And what is the probability of it actually landing on tails if we have one coin, right? That would be an example of experimental probability, because you actually performed the experiment, and when you performed the experiment, you recorded what was actually happening at that as you did it. See what I'm saying? See how it differs from theoretical probability? Theoretical probability is the inherent nature of that thing being studied. So if you were to flip a coin, for example, and you said, well, based on the fact that it has two faces, the theoretical probability is that it lands, that is a 50% chance that it lands on heads or tails. That would be its theoretical probability. But let's say you actually flip the coin, right? And you said, okay, I did the trial 5 times. And when I did the trial 5 times, that when I flipped the coin, it landed on heads 3 times and it landed on tails 2 times. Then you would say that there's a 60% chance that it landed on heads, and there is a 40% chance that it landed on tails, right? So for example, like if I did the trial 5 times and I flipped the coin, I flipped one coin, and I said, okay, I did the 5 trials, and when I flipped it 3 times, the first trial was heads, the first one was heads, the second one was heads, the third one was heads, the fourth one was tails, and the fifth one was tails. Then the experimental probability would be that probably that 3/5 of the time, it landed on heads, which means that 3/5 is 60%, right? And that if it landed on tails 2 out of the 5 times, then it was 40%. That is the experimental probability, because it's when we actually did the experiment, is when we actually performed it. You see what I'm saying? Okay. All right. So basically, in a nutshell, for this video, what you basically want to understand, at least into an introduction into probability, is that probability means that it's the likelihood of something happening. In an everyday to day sense, when we talk about probability, we use words like, what is the chance of something happening, right? We also use words like we'll use words like likelihood, chance. You know, I'm certain that this will occur. I'm certain. Certainty means that you're like 100% sure, right? I'm uncertain, right? Uncertainty means that you're not 100% confident that the thing will occur, with this or that will occur, right? Or I'm 50% sure. Or I'm like, you would use words like that when you're talking about probability, or when you're talking about chance, or you're talking about something that you don't have full knowledge on. Probability deals with things which you don't have full information, you don't have perfect information, right? Games that have perfect information, such as chess, such as Go, are games of perfect information, because there is no element of chance. But games like, for example, like like poker, like spades, like stuff like that, that has an element of chance. Those games are like the nature of probability. Those games use probability and they use chance, right? Probability is broken down into theoretical and experimental probability. Theoretical probability is dealing with the actual nature of the thing being studied, like flipping a coin, right? Experimental probability deals with when you actually perform the experiment and you record what actually occurred, what actually happened in reality, right? And you would say, well, based on my experiment, this is what actually occurred, right? That's basically what it is in a nutshell. There is more complex ideas dealing with probability, such as the sample space and like, you know, more theoretical concepts dealing with probability. But for the purposes of this video, this is what it is in a nutshell, or the basic idea of probability. We will go into more complex ideas dealing with probability in a future video, but for the purposes of this video, you just have to understand what it is currently, right? Just understand the basic idea. So that's it. Thank you for your time, and I hope to make a new video soon. Bye-bye.